Hi, hello. Welcome back to i-TUTOR NCERT series. Today we are going to discuss Class 8 Geography NCERT Chapter 3 Mineral and Power Resources. A naturally occurring substance that has a definite chemical composition is a mineral. So this is a definition of mineral. What is mineral? A naturally occurring substance. Okay, so minerals are naturally occurring substance that has a definite chemical composition. Okay, so those are called minerals. Minerals are not evenly distributed over space. They are concentrated in a particular area or rock formation. Okay, so they are concentrated in a particular area or rock formations. Some minerals are found in areas which are not easily accessible, such as the Arctic Ocean bed and Antarctica. So these are places which are very hard to accessible. Okay, those are places that's not easily accessible, and that examples are Arctic Oceans and Antarctica. So in Arctic Ocean bed and Antarctica, the minerals are found abundant. Okay, so minerals are formed in different types of geological environment under varying conditions. They are created by natural process without any human interference. They can be identified on the basis of their physical properties such as color, density, hardness, and chemical properties such as solubility. Okay, so the minerals can be identified by both physical and chemical properties. Physical properties like color, density, hardness, and chemical properties like solubility. Okay, so that's about mineral. Now, types of mineral. There are over 3000 different minerals. On the basis of composition, minerals are classified mainly as metallic and non-metallic minerals. Okay, so the minerals are classified as metallic and non-metallic. The metallic minerals are then again classified into ferrous metallic minerals and non-ferrous metallic minerals. Now, what is metallic minerals? Metallic minerals contain metal in raw form. Okay, so the metallic minerals contain metal in raw form. Metals are hard substances that conduct heat and electricity. So metals conduct heat and electricity and have a characteristic luster or shine. Okay, so what is metal or metallic substance? They are hard substance that conduct heat and electricity and they have a characteristic luster or shine. Iron ore, bauxite, manganese ore are some example. So these are some examples of metallic minerals. Iron ore, bauxite, manganese ore. So these are examples of metallic minerals. Metallic minerals may be ferrous or non-ferrous. Okay, so we already classified metallic minerals into ferrous and non-ferrous. So here also they are classified as ferrous or non-ferrous. Ferrous minerals like iron ore, manganese and chromates contain iron. Okay, so the ferrous minerals contain iron. Okay, they have iron content in them. A non-ferrous mineral does not contain iron. Okay, non-ferrous mineral does not contain iron but may contain some other metal such as gold, silver, copper or lead. Okay, so that's about metallic and non-metallic minerals. Okay, minerals can be classified into metallic and non-metallic on the basis of composition. Okay, basis of composition they can classify into metallic minerals and non-metallic minerals. The metallic minerals are then classified into ferrous and non-ferrous. The ferrous minerals are iron ore, manganese, chromates which contain iron, and non-ferrous minerals are they does not contain iron but they may contain some other metals like gold, silver, copper or lead. Okay. Now, second one is non-metallic mineral. Non-metallic minerals do not contain metal. Okay, so as the name denotes, they do not contain metal. Limestone, mica and gypsum are example of such minerals. Okay, so in limestone, mica and gypsum they does not contain metals. So that's why they are known as non-metallic minerals. The mineral fuels like coal and petroleum are also non-metallic minerals. Okay, we already know about the fuels like coal and petroleum. They are also non-metallic minerals. Okay, now minerals can be extracted by mining, drilling or quarrying. Okay, so the minerals can be extracted by the process of mining, drilling or quarrying. First one is mining, then drilling and final one is quarrying. Mining are of two types. First one open cast mining and shaft mining. Okay. Now, what is this? The process of taking out minerals. Okay, the process of taking out minerals from rocks buried under the earth's surface is called mining. So what is the process of mining? Mining is the process of taking out minerals from rocks buried under the earth. Okay, so the extraction of minerals from the earth, that process is called mining. Minerals that lies at shallow depths are taken out by removing the surface layer. This is known as open cast mining. Okay, so what is open cast mining? Open cast mining means the minerals that lies at shallow depths, okay, are taken out by removing the surface layer. Only they need to remove the surface layer and they get the mineral. So this process, or this is called open cast mining. Now, deep bores called shaft have to be made to reach mineral deposits that lies great depth. Okay, so in for some minerals they need to they need to dig a large part or deep bores. So this is called a shaft. These deep bores are called a shaft, and they have to made to reach the mineral deposit that lies at a great depth. Okay, so this process or these types of mining is called shaft mining. Okay, because the minerals are inside the earth. Okay, they are in a deep inside the earth. So that's why we need to bore the we need deep bores, and these bores are called shaft. Okay, so by this method they are called shaft mining. So first one is open cast mining. It's removing the surface layer and simple process, and that's called open cast mining. Second one is deep minerals are extracted by this process, that is called a shaft mining. Now, petroleum and natural gas occur far below the earth's surface. Deep wells are bored to take out them. This is called drilling. Okay, so like petroleum and petroleum and natural gas, they are occur far below the earth's surface. To extract them or to take them out, we need to dig a deep well. So these types of mining are called, this is called drilling. Okay, so first one is mining. Mining is of two types. First one is open cast mining and shaft mining. Okay, open cast mining is used for extract the minerals from a shallow depth. Okay, and shaft mining is used to extract the minerals from a great depth. And second process is drilling. Petroleum and other natural gases, they are far below the earth's surface. So to take them out, we need to dig a deep well. So this process is called drilling. Now, minerals that lie near surface are simply dug out by the process known as quarrying. Okay, so the third one is quarrying. What is quarrying? Minerals that lie near the surface. Okay, lie near the surface are simply dug out. Okay, they can easily dug out by the process known as quarrying. Okay, so that's about the extraction of minerals. There are three methods. First one is mining, second one is drilling, and final one is quarrying. The mining is of two types. First one is open cast mining. This is used to extract shallow depth minerals. Second one is shaft mining. This is used to extract great depth minerals. Okay, now moving forward. Distribution of minerals. Minerals occur in different types of rocks. Some are found in igneous rocks, some in metamorphic rocks, while others occur in sedimentary rocks. We know there are three types of rocks. First one is igneous rocks, and second one is metamorphic rocks and sedimentary rocks. So minerals occur in different types of rocks. They may be occur in igneous or maybe in metamorphic or in sedimentary rocks. Generally, metallic minerals are found in igneous and metamorphic rocks. Okay, generally the metallic minerals, they are found in igneous and metamorphic rocks. Okay, so generally the metallic minerals, metallic minerals are mainly found in igneous or metamorphic rocks. Now, and the formation of large plateaus. Okay, these rocks form large plateaus. Iron ore in the North Sweden, copper and nickel deposition in Ontario, Canada. Then iron and nickel and chromates and platinum in South Africa are examples of minerals found in igneous and metamorphic rocks. So the minerals found in igneous and metamorphic rocks are mainly found in where iron ore in North Sweden, copper and nickel deposits in Ontario, Canada, iron, nickel, chromates and platinum in South Africa. So these are the examples of minerals that found in igneous and metamorphic rocks. Now, sedimentary rock formations of plains and young fold mountains contain non-metallic minerals. Okay, basically the sedimentary rock formation of plains and young fold mountains contain non-metallic minerals. Okay, for example, limestone. Okay, so the igneous and metamorphic rocks formation contain mainly metallic minerals, but the sedimentary rocks formation contain non-metallic minerals like limestone. Limestone deposits of Caucasus region of France, manganese deposit of Georgia and Ukraine, then phosphate beds of Algeria are some examples. So these are examples for the non-metallic minerals. Now, mineral fuels such as coal and petroleum are also found in the sedimentary strata. So the mineral fuels such as coal and petroleum can also see in the sedimentary strata. Okay, so that's about the distribution of minerals. Now, mineral contents on the continents. Look at this. First one is Asia. China and India have large iron ore deposit. Okay, so China and India have large iron ore deposit. The continent produces more than half of the world's tin. Okay, so Asia produces more than half of the world's tin. Okay, so Asia produces more than half. Okay, more than half of the world's tin. China, Malaysia and Indonesia are among the world's leading tin producers. So the China, then Malaysia and Indonesia, these are among the world's leading tin producers. Now, China also leads in production of lead, antimony and tungsten. Asia also has deposits of manganese, bauxite, nickel, zinc and copper. Okay, so next one is Europe. Europe is the leading producer of iron ore in the world. The countries with large deposit of iron ore are Russia, Ukraine, Sweden and France. So Europe is the leading producers of iron ore in the world, and mainly countries like Russia, Ukraine, Sweden and France have the large deposits of iron ores. Minerals deposits of copper, lead, zinc, manganese and nickel are found in the Eastern Europe and European Russia. Okay, so minerals like copper, lead, zinc, manganese and nickels are found in the Eastern Europe and European Russia. Next one is North America. The mineral deposits in North America are located in three zones. First one is the Canadian region north of the Great Lakes. Okay, so the first region is Canadian region, that is north of Great Lakes. The Appalachian region and the mountain regions of the west. Okay, so the next one is Appalachian region and final one is the mountain ranges of the west. So in North America, the minerals deposits are mainly found in three zones. First one is Canadian region, then second one is Appalachian region and final one is mountain ranges of the west. Now, iron ore, nickel, gold, uranium and copper are mined in the Canadian Shield region. Coal in the Appalachian region. Okay, so mainly the iron ore, nickel, gold, uranium and copper are found in the Canadian Shield region, and the Appalachian regions contain coal deposition. Western Cordilleras have vast deposit of copper, lead, zinc, gold and silver. Okay, so that's about the North American continent. Next one is South America. Brazil is the largest producer of high-grade iron ore in the world. Chile and Peru are leading producers of copper. Brazil and Bolivia are among the world's largest producers of tin. South America also has large deposit of gold, silver, zinc, chromium, manganese, bauxite, mica, platinum, asbestos and diamond. Then mineral oil is found in Venezuela, Argentina, Chile, Peru and Colombia. Okay, so the Brazil is the largest producer of high-grade iron ore in the world. Then Chile and Peru are the leading producers of copper also. Now, next one is Africa. Africa is rich in mineral resources. It is the world's largest producers of diamond, gold and platinum. So Africa is the largest producers of diamonds, gold and platinum. South Africa, Zimbabwe and Sierra produce a large portion of the world's gold. The other minerals found in Africa are copper, iron ore, chromium, uranium, cobalt and bauxite. And also oil is found in Nigeria, Libya and Angola. Okay, so the Africa is the largest producer, world's largest producers of diamond, gold and platinum, and also they contain oils found in Nigeria, Libya and Angola. Now, Australia. Australia is the largest producers of the bauxite in the world. Okay, so Australia is the largest producer of bauxite in the world. It's a leading producer of gold, diamond, iron ore, tin and nickel. It's also rich in copper, lead, zinc and manganese. Kalgoorlie and Coolgardie areas of Western Australia have a large deposit of gold. Okay, so in this area, this is Western Australia and that's a desert region. So the Kalgoorlie and Coolgardie area of Western Australia have a large deposit of gold. Now, the final continent, last continent is Antarctica. The geology of Antarctica is sufficiently well known to predict the existence of a variety of mineral deposits, some probably large. Significant size of deposits of coal in the Trans-Antarctic Mountains and iron near the Prince Charles Mountain of East Antarctica is forecasted. So, the significant size of deposits of coal in the Trans-Antarctic Mountains and the iron near Prince Charles Mountain of East Antarctica is forecasted. Now, the iron ore, gold, silver and oil are also present in commercial quantities. Okay. Now, distribution of minerals in India. First one is iron. India has deposits of high-grade iron ore. The minerals is found mainly in Jharkhand, Odisha, Chhattisgarh, Madhya Pradesh, Goa, Maharashtra and Karnataka. So, the iron are mainly found in the states of Jharkhand, Odisha, Chhattisgarh, Madhya Pradesh, Goa, Maharashtra and Karnataka. Then bauxite. Major bauxite producing areas are Jharkhand, Odisha, Chhattisgarh, Madhya Pradesh, Gujarat, Maharashtra and Tamil Nadu. Next one is mica. Mica deposits mainly occur in Jharkhand, Bihar, Andhra Pradesh and Rajasthan. Now, India is the largest producer and exporter of mica in the world. Okay, so India is the largest producer and exporter of mica in the world. Now, copper. It is mainly produced in Rajasthan, Madhya Pradesh, Jharkhand, Karnataka and Andhra Pradesh. Next one is manganese. India's manganese deposits lies in Maharashtra, Madhya Pradesh, Chhattisgarh, Odisha, Karnataka and Andhra Pradesh. Now, limestone. Major limestones producing states in India are Bihar, Jharkhand, Odisha, Madhya Pradesh, Chhattisgarh, Rajasthan, Gujarat and Tamil Nadu. Next one is gold. The Kolar region in Karnataka has deposits of gold in India. These mines are among the deepest in the world, which makes mining of this ore is very expensive process. Okay, so these mines are very deep. That's why the mining process is very expensive. Okay, the place is Kolar in Karnataka. Now, final one is salt. It is obtained from seas, lakes and rocks. India is one of the world's leading producer and exports of salt. Look at this picture. This is a coring of limestone process and this is extraction of salt from Samba Lake in Rajasthan. Now, uses of minerals. Minerals are used in many industries. Minerals which are used for gems are usually hard. These are then set in various styles of jewelry. Copper is another metal used in everything from coins to pipes. So, from coins to pipes we can use copper. Okay, we can see the copper presence. Silicon used in the computer industries is obtained from quartz. So, silicon is obtained from quartz. Aluminium obtained from its ore. Bauxite is used in automobiles and airplanes, bottling industries, building and even kitchen cookware. So, aluminium is used in everywhere, like especially the bauxite ore, especially in automobile industries, aeroplanes, bottling industries, building and even kitchen cookwares. Now, how to conserve this mineral? It's conservation of minerals. Minerals are a non-renewable resource. So we know minerals are non-renewable resource. It takes thousands of years. We already know that. Okay, non-renewable means it takes thousands of years to reformation. So it takes thousands of years for the formation and concentration of minerals. The rate of formation is much smaller than the rate at which the human consume these minerals. Okay, so the rate of formation is very less than the consuming level. It is necessary to reduce the wastage in the process of mining. Now, recycling of metal is another way in which the minerals resources can be conserved. Okay. Next one is power resources. Power or energy plays a vital role in our lives. We also need power for industry, agriculture, transport, communication, defense, etc. etc. So, power resources may be broadly classified as or categorized as conventional and non-conventional resources. Okay, so the power resources can be classified into conventional and non-conventional resources. So, what is conventional resources? So, conventional resources are those resources of energy, those which have been common use for a long time. Okay, so conventional sources of energy are those which have been in common use for long time. Okay, they can use in a long time. Firewood and fossil fuels are the two main conventional energy sources. Okay, example of conventional energy sources are firewood and fossil fuels. Firewood. It is widely used for cooking and heating. In our country, more than 50% of the energy used by villages come from the firewood. Okay, so in India, more than 50% of the energy used by villages come from the firewood. Remains of plant and animals which were buried under the earth for millions of years got converted by the heat and pressure into fossil fuels. So how fossil fuels made the remains of plants and animals which were buried under the earth for millions of years, and they got converted by the heat and pressure into fossil fuels. Now, the fossil fuels like coal, petroleum and natural gas are the main sources of conventional energy. Okay, so these are the examples of conventional energy: coal, petroleum and natural gas. The reserves of these minerals are limited, so their availability or their quantity is very less, limited quantity. The rate at which the growing world population is consuming them is far greater than the rate of their formation. So these are likely to be exhausted soon. Okay. Now look at this picture. This is the conventional source of energy. First one, oil and natural gas. Then here firewood, coal, hydropower. Okay. So these are examples for the conventional source of energy. They have both advantages and disadvantages. Now, coal. This is the most abundantly found fossil fuel. It is used as a domestic fuel in industries such as iron and steel, then steam engines, and to generate electricity. So, the coal can be used in the domestic fuel, okay, used as a domestic fuel in industries such as iron and steel, then steam engines, and to generate electricity. Okay, so this is most abundantly found fossil fuel. Electricity from coal is called thermal power. The coal which we are using today was formed millions of years ago when giant fans and swamps got buried under the layers of earth. Coal is therefore referred as the buried sunshine. Okay, so that's why the coal is known as buried sunshine. The leading coal producers of the world are China, USA, Germany, Russia, South Africa and France. The coal producing areas of India are Raniganj, Jharia, Dhanbad and Bokaro in Jharkhand. Okay, so these are the leading producer of coal in India. Okay, the places of coal producing in India: Raniganj, Jharia, Dhanbad and Bokaro in Jharkhand. Next one is petroleum. The petrol that keeps your car running as well as the oil that keeps your cycle from squeaking both begins as a thick black liquid called petroleum. Okay. It is found between the layers of rocks and is drilled from oil field. The petrol is found between the layers of rocks and they are extracted by the process of drilling. Located in the offshores of coastal areas. They are mainly located in the offshores and coastal areas. Okay, so the petroleum products can be mainly located in the offshores and coastal areas. This is then sent to refineries which process the crude oil and produce a variety of products. For example, diesel, petrol, kerosene, wax, plastic and lubricants. Okay, so these are the products of petroleum. Petroleum and its derivatives are called black gold. Okay, the petroleum and its derivatives are called black gold. Why? Because they are very valuable. The chief petroleum producing countries are Iran, Iraq, Saudi Arabia and Qatar. Okay, so the chief petroleum producing countries are Iran, Iraq, Saudi Arabia and Qatar. The other major producers are USA, Russia, Venezuela and Algeria. The leading producers in India are Digboi in Assam, Bombay High in Mumbai and the deltas of Krishna and Godavari rivers. Okay, so these are the leading producers in Indian places. Digboi in Assam, Bombay High in Mumbai and the delta of Krishna and Godavari rivers. Next one is natural gas. Natural gas is found with petroleum deposit and is released when crude oil is brought to the surface. It can be used as a domestic and industrial fuel. Russia, Norway, UK and the Netherlands are the major producers of natural gas. Okay, so the natural gas is found with the petroleum deposits and they are released when the crude oil is brought to the surface. So this can be used as domestic as well as industrial fuel. Now, in India, Jaisalmer, Krishna Godavari Delta, Tripura and some areas offshore in Mumbai have natural gas resources. So in India, we can see the natural gas resources in Jaisalmer, Krishna Godavari Delta, Tripura and some areas offshore in the Mumbai region. Okay. Very few countries in the world have sufficient natural gas reserves in their own. The sharp increase in our consumption of fossil fuels has led to the depletion at an alarming rate. The toxic pollutions released from these fuels are also a cause for concern. Unchecked burning of fossil fuel is like an unchecked dripping tap which will eventually run dry. This has led to the tapping of various non-conventional sources of energy that are cleaner alternative to fossil fuels. Okay, so the increasing use of fossil fuels are making many problems in our environment. Now, hydel power. These are some alternatives for fossil fuel. Okay, so first one is hydel power. Rainwater or river water stored in dams is made to fall from heights. The falling water flows through pipes inside the dam over turbine blade placed at the bottom of the dam. The moving blades then turn the generator to produce electricity. So this process is called hydroelectricity. Okay, electricity from the water. So that's why the name hydroelectricity. The water discharged after the generation of electricity is used for irrigation. 1/4 of the world's electricity is produced by hydel power. Okay, so the 1/4 of the world's electricity that is produced by the hydel power. The leading producers of hydel power in the world are Paraguay, Norway, Brazil and China. Some important power stations in India are Bakranangal, Gandhi Sagar, Nagarjun Sagar and Damodar Valley projects. Okay, so these are the main hydel power stations in India: Bakranangal, Gandhi Sagar, Nagarjun Sagar and Damodar Valley. Now, non-conventional source of energy. The increasing use of fossil fuels is leading to its shortage. It is estimated that if the present rate of consumption continues, the reserves of these fuels will get exhausted. Moreover, their use also causes environmental pollution. Therefore, there is need for using non-conventional sources such as solar energy, wind energy, tidal energy, which are renewable. Okay, so these are renewable resources and they are called non-conventional sources. First one is solar energy. Sun's heat and light energy can be felt by us every day. Solar energy trapped from the sun can be used in solar cells to produce electricity. Many of these cells are joined into solar panels and these generate power for heating and lighting purpose. The technology of utilizing solar energy benefits a lot of tropical countries that are blessed with abundant sunshine. Solar energy is also used in solar heaters, solar cookers, solar dryers, besides being used for community lighting and traffic signals. Okay, so the solar energy is used in many fields such as solar cookers, solar diodes, and community lighting, traffic signals, etc. Okay, and they are non-conventional energies. Next one is wind energy. Wind is an inexhaustible source of energy. Windmills have been used for grinding grain and lifting water since times immemorial. But in the modern time windmills, the high-speed winds rotate the windmills, which is connected to a generator to produce electricity. So the high-speed winds rotated the windmills, and that is connected to a generator, and which produce electricity. Wind farms having clusters of such windmills are located in the coastal regions and in mountain passes where strong and steady winds blow. Okay, so they are mainly located in the coastal regions and mountain passes because there are abundant, strong and steady winds. Now, wind farms are found in Netherlands, Germany, Denmark, UK and USA. Now, nuclear power. Nuclear power is obtained from energy stored in the nuclei of atoms of naturally occurring radioactive elements like uranium and thorium. These fuels undergo nuclear fission in nuclear reactors and emit power. So the process is known as nuclear fission. Okay, when this fuel undergo the nuclear fission process and the nuclear reactor emit power. The greatest producers of nuclear power are USA and Europe. In India, Rajasthan and Jharkhand have large deposits of uranium. Thorium is found in large quantities in the monazite sands of Kerala. The nuclear power stations in India are located in Kalpakam, Tamil Nadu, Tarapur, Maharashtra, Rana Pratap Sagar near Kota in Rajasthan, then Narora in Uttar Pradesh and Kaiga in Karnataka. So these are the nuclear power stations in India. Again, Kalpakam in Tamil Nadu, Tarapur in Maharashtra, Rana Pratap Sagar near Kota, that is in Rajasthan, then Narora in Uttar Pradesh and Kaiga in Karnataka. Okay. Next one is geothermal energy. Heat energy obtained from the earth is called geothermal energy. So what is geothermal energy? It's the heat energy that's obtained from the earth, that is called geothermal energy. The temperature in the interior of the earth rises steadily as we go deeper. So we know when we go deeper, the temperature of the interior of the earth increases. Okay. Sometimes this heat energy may surface itself in the form of hot spring. Okay, but in sometimes this heat energy came to a surface in the form of hot spring. This heat energy can be used to generate power. Geothermal energy in the form of hot springs has been used for cooking, heating and bathing for several years. USA has the world's largest geothermal power plants, followed by New Zealand, Iceland, Philippines and Central America. In India, geothermal plants are located in Manikaran in Himachal Pradesh and Puga Valley in Ladakh. So in India, the geothermal plants are located in Manikaran in Himachal Pradesh and Puga Valley in Ladakh. Next one is tidal energy. The energy generated from tide is called tidal energy. Tidal energy can be harnessed by building dams at narrow opening of the sea. During high tides, the energy of the tide is used to turn the turbine installed in the dam to produce electricity. So during the high tide and low tide time, the turbines installed in the dam produce electricity. Russia, France and the Gulf of Kutch in India have huge tidal mill farms. Okay, so in India, mainly the Gulf of Kutch region have huge tidal mills. Now, the final one is biogas. Organic waste such as dead plant and animal material, animal dung and kitchen waste can be converted into a gaseous fuel called biogas. Okay, so the kitchen waste, then dead plant, animal material, animal dung, etc. They can be converted into a gaseous fuel. This is called biogas. The organic waste is decomposed by bacteria in biogas digesters to emit biogas, which is essentially a mixture of methane and carbon dioxide. So the biogas contains methane and carbon dioxide. This is an excellent fuel for cooking and lighting and produce huge amount of organic manure each year. So this already used for the lighting purpose and cooking purpose, and also they produce huge amount of organic manure, which is useful for the agriculture purpose. Now, energy is everywhere, but we can see that harnessing this energy is both difficult as well as costly. Each one of us can make the difference by not wasting energy. So energy saved is energy generated. Act now and make brighter energy future. Look at this picture. This is a biogas plant. Okay. So that's about this chapter. For any doubts, you can comment below. For more videos, do like, share, subscribe.